Hello everyone, today we are going to discuss about CRC. CRC stands for Cyclic Redundancy Check. This cyclic redundancy check is one of the error detection method which is used in the data link layer. CRC is a method of detecting accidental changes or error in the communication channel. CRC uses generator polynomial which is available on both sender and receiver side. An example an example generator polynomial is in the form of a equation, that is x cube plus x plus 1. So the generator will be given in the form of a polynomial equation. So before we start solving the problem in detail, let us discuss 2 points, that is n and k. Here n is also known as data, the data which is given to solve in the CRC problem, and the CRC is mainly used to check the it is mainly used for the error detection in the communication. So when we communicate we cannot assure that in the communication the actual data will be sent from sender to the receiver. So when, say for example, when I am saying hello, so the hello will be transmitted in the form of a binary value, and that binary value will be sent to the receiver. And here the data will be taken in the form of a binary value. Say for example, data is equal to 100,100. So data is also represented with n, that is number of bits in data to be sent from sender side. So this is the, so what the example I have taken here, 100,100 is a number of bits in data to be sent from sender side. And here we have a k is nothing but the generator, number of bits in the key obtained from generator polynomial. The generator will be given in the form of a polynomial equation, that is x cube plus x plus 1, or else in some situation the generator will be given directly in the form of a binary value. Now let us convert this polynomial equation into a binary value. First, let us check what is the highest root in this given polynomial equation, that is x cube. So x cube 1, and do we have any value for x square? No. So for that take 0. Then x to the power 1. Yes, we have one value. Then 1. So this is how we are converting the polynomial generator into a binary value. So this is the plain data given for the communication, and this plain data will be sent from the sender to the receiver. And we are going to check that whether the same data we are transmitting to the receiver, if we are transmitting the same data in the CRC calculation, the remainder will be 0. If at all any mismatch in the data, then the remainder will not be 0. So now the question is, what do you mean by mismatch? So the data which we are transmitting here in the form of a zeros and ones. So when I say mistake, then 1 will become 0 and 0 will become 1. Yes, this is, so when the data is not, when the data is not 1, then what it will be? When we are talking about, we are saying it will be in the form of a binary value. Then 1 will become 0 and 0 will become 1. So in the communication, in the cyclic redundancy, along with the plain data, we are going to append some parity bits in the communication. Now the question is, how many parity bits we have to append to the plain text, that is k minus 1 or L minus 1. Now the question is, what is L? L is nothing but the size of the binary values in the generator. What is the size of binary value in the generator? That is 4. So 4 minus 1 is equal to 3. So 3 bits we have to append to the given data, that is 0 0 1. So these 3 extra bits, we have to append zeros to this given text. Now we are going to solve this using a division method. Here will be the divisor. The divisor will be the generator, that is 1 0 1 1. So this is using this given expression we have calculated this generator. But to solve this problem, I am taking a generator. I am taking a generator 1 1 0 1. So this is the given data. This is the generator, that is 1 1 0 1 1 double 0 1 double 0 triple 0. Why we are adding these triple zeros? Because we have to append three zeros. We have to append zeros, not three zeros, student. Three zeros. We have to append zeros. Now, how we have decided only three zeros we have to append? Using this formula, that is L minus 1. Now, we are going to divide this given data with the divisor 1 1 0 1. 1 1 is 0, 0 0 is 0, 0 1 is 1, 1 1 is 0. Yes, so we are not going to consider, we are going to consider the most significant value. The most significant value is 1. So next, take a next value 0 1 1 1 0 1 1 0 1 0 1 0 1 1 0 1. Here we are performing XOR operation 0 1 1 1 0 0 0 1 1 1 1 is 0. Sorry, student. Sorry. Here 1 0 is 1. Take a next value 0 1 1 1 0 1. Oh, sorry. 1 minute. 1 that is 1 1 0 1 0 1 1 1 0 1 0 1 1 1 1 0. So take a next value 0. Next 1 1 1 0 1 0 1 1 1 0 0. Sorry, 1 0 is 1, 1 1 is 0, 1 1 is 0. So here we got two zeros and the remainder we have two ones. So as I told before, we are going to consider from the 1, because 1 is a most significant value. Then after 1 we have only one more digit, then only two digits we have. So at a time 2 I can take a carry 2 1 1 0 1 1 0 0. So this is the CRC value generated at the sender side. Now we have to calculate the CRC value at the receiver side. And one more important point here is, so this is the plain text or the plain data we have and that is given in the question. At the sender side we have appended 3 zeros to this given plain data. Now to calculate the CRC value at the receiver side, we have to append these CRC values, that is 001. So the job of a sender is to generate CRC value. Now let us calculate the value at the receiver side. 1101, 100, 100, 001. Ones are 1, 1, 0, 1, 1, 1, 0, 0, 0, 0, 0, 1, 1. This is 0. Take a next value 0. So 1, 1, 1, 0, 1, 0, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Take the next value 0, 1, 1, 1, 0, 1, 1, 1, 1, 0. So will take the next value 0, 1, 1, 0, 1. That is 0, 1 is 1, 1, 0 is 1, 1, 1 is 0, 1, 1 is 0. Next, we have two zeros and two ones. So the significant after the significant value 1, we have only one value. So directly I can take here two values. That is 0, 1, 1, 1, 1, 0, 1, 0, 0, 0. So the remainder is 0 at the receiver end. Remainder is, this means there is no mismatch in the communication. The whatever the data is transmitted in the CRC, the actual data is transmitted. Thank you.